compares adjacent leg divided by hypotenuse. And then you have your last trig function, which is tangent, and it compares opposite leg divided by adjacent leg. And so what we've been saying in class, and some of your other teachers have been saying, is they just pronounce this, and they say SOHCAHTOA, and that's what helps them remember the trig functions and the ratios. There's other ways of memorizing them. Some teachers will use an acronym, and they'll say, some old hag clipped all her toenails outside Albertsons. There's a bunch out there, but somehow you do need to commit these 3 trig functions to memory. Now, in the previous video, we started working on number 16 here, and we came to the conclusion that if we are considering that our perspective is here at the angle 64, then we have our opposite side, and we need our adjacent leg. So these are both the legs. Now, we don't have the hypotenuse's length because it is right here. It's always opposite the 90-degree angle. We don't have the hypotenuse, but we're also not looking for it. So for this one question, we don't need to bother with the hypotenuse at all. We don't have its length, and also the question is not asking us to search for it. So you ask yourself, what trig function involves opposite and adjacent legs? And that is tangent. That is how you choose which one of the 3 trig functions you use. After you write the trig function, in a set of parentheses, you will write your angle measurement that is printed on the piece of paper. In this case, that's 64. And then you set that equal to the ratio. Tangent is opposite leg, which is 17 in this diagram, divided by your adjacent leg, which is x. Now from here, this is just setting up. You do not use your calculator for any of this. This is just logic and knowing your trig functions. From here, though, we need to solve for x. And this is how I want all of my students to solve for x. No matter where x is, maybe it's the angle measurement, maybe it's the numerator, or like this one, maybe it's the denominator. The next thing I need everyone to do is to write the tangent of 64, put that over 1. Because tangent of 64 is some number. It is a constant. So this is just some number, and so if I have the whole number 8, and I want to represent that as a fraction, we just put it over 1. So it's the same thing here. Tangent of 64 is just some number. And when we put it over 1, that doesn't affect the value at all. However, when doing so, now this is a fraction or ratio set equal to another fraction or ratio. Well, when you have 2 ratios that are set equal to each other, that is called a proportion. And we can cross multiply and solve for this variable. I'm going to make it so that when I take the cross product, because there's clearly going to be a product on the left-hand side, and there's going to be a product on the right-hand side, I'm going to make it so that the variable is always on the left-hand side of the equation. So my 2 cross products are going to be 1 times 17, which is 17. Now that doesn't have the variable involved in it. That's why I'm going to put it over here on the right-hand side. My other product is the variable x times tangent of 64. So let's just write that out. We have x times the tangent of 64. So this right here in blue ink is my cross product. Now, we need to get x by itself. And so just like way back in the day in Algebra 1, if you had 3x is equal to 7, Then to get x by itself, you would divide by 3, because that was the inverse operation. Division was the inverse operation. And you always divided by that same value so that they reduce down to 1 and all you're left with is just your variable. And you had your answer. We've also been doing this with the special right triangles, that if we had that the hypotenuse was 10 of a 45, 45, 90 triangle, then this is the equation we'd set up, and we would have to divide both sides by the square root of 2. Because the square root of 2 is just some value, and then these would cancel out. You were left with the length of the leg is equal to 10 divided by the square root of 2, and then we would rationalize the denominator and etc. Well, the same thing's happening over here. This is a variable being multiplied by some value. We've been multiplied by some value. So what we're going to do is divide, which is the inverse operation. We're going to divide both sides of the equation by tangent of 64. By dividing on the left-hand side by the tangent of 64, these two reduce down to just 1. And so we're left with only x on the left-hand side, and on the right-hand side we have 17 divided by the tangent of 64. And for now, I want us to stop here. This is our exact answer. This is our exact answer. And this is the answer that I want on next homework that's due next class, is the exact answers. And the reason is because we didn't touch our calculators and we didn't have to find out what this value of tangent 64 is, but everybody can do this at home no matter what they have. I wanted to go through a couple more examples with you. On page 140, I wanted to take a look at number 18 with you all. Now, again, I can't say this enough, but please use the angle that is printed. So the angle that is printed on the piece of paper that was given to us is 39 degrees. And so I'm going to use this angle to solve for G and to solve for H. I'm going to go ahead and label my side lengths with respect to this angle, 39 degrees. This side here that's labeled, that's being represented by the variable G, that obviously is our hypotenuse. The hypotenuse is always opposite of your 90-degree angle. This side here, that's its length being represented by the variable H, this is on the complete opposite side of the angle that we are using for these problems. And so this is the opposite leg. And then by default, the only one remaining is adjacent leg. Because this leg of this right triangle, the leg is, this is the one that's right next to the angle that was printed for us, that was given to us, angle 39. So I've labeled everything I have. Now, we need to figure out which trig function we need to solve for H and G. We're going to take one at a time. First, in blue ink, I'm going to solve for the variable H. So, you need to go through that same process of what do I know and what do I need to know, or what am I looking for. So, I know I have the adjacent leg, that is 44 units. I need to know, this acronym, need to know. I need to know, well, H is the opposite leg. So I've got my adjacent leg, I need my opposite leg. So then you ask yourself, which one of the three trig functions involves opposite and adjacent leg together. And so at the top of your quiz or test, you should have the trig functions written out, however you have decided to memorize those. But I can see that tangent, its ratio is opposite divided by adjacent. And so that's what I need. And so this is how you choose the trig function that you need to use to solve for that side length or that variable. So tangent of my angle, which is 39 degrees, is equal to, and this is where you write the ratio. Tangent is opposite divided by adjacent. So my opposite side is h. My adjacent leg is 44. So now I'm going to, so I've got the ratio written out. Immediately after that, you put the trig function over 1. This is when you're looking for a side length. You put the trig function over 1, and then you cross multiply. Making sure that your two products that you have, make sure the variable ends up on the left. So I have 1 times h. Well, h is my variable. I want that on the left-hand side. So h is one of my cross products. 1 times h. My other cross product is going to be 44, this value, times, so I'm going to put a dot to represent multiplication, tangent of 39. And that is your exact answer. And so for this problem, you have already found your exact answer just by simply taking the cross product, because you know that that length, the length of the opposite leg, h, is 44 times the tangent of 39, which is our angle measurement. All right, now let's solve for the other side length. I'll do it in green. So now in green ink, we're looking for our hypotenuse. So I'm just going to keep on writing down here. So again, we want to write out what we know and what we need to know. Use what is printed on the piece of paper. Do not use some value that you have found on your own. Use what is printed on the paper. So I know that the adjacent leg is 44. That was printed on the piece of paper. I need to know my hypotenuse. So then you ask yourself, okay, well, which trig function involves the adjacent leg and the hypotenuse? And so you look and you say, okay, well, adjacent and hypotenuse, that is cosine. And that is how you choose which trig function you're going to use. So cosine of my angle, 39 degrees, because that's the one that we're given, and that's one we're using, is equal to, and then we're going to go ahead and write this cosine ratio. Well, cosine compares adjacent divided by hypotenuse. So my adjacent leg length is 44 in the diagram, and my hypotenuse is what I'm looking for, represented by the variable g. Once you have your trig ratio set up and all your values plugged in, first step is to put the trig function over 1. Again, this is when you're solving for a side length. Put the trig function over 1. And then take your cross product, but make it so the variable is on the left-hand side. So one of my cross products is 1 times 44. That's just simply 44. And because that doesn't have a variable involved, I'm going to put that on the right-hand side. My other cross product is g times cosine of 39, whatever that is. So g times cosine of 39. Now I need to get g by itself, so I'm going to divide both sides of the equation by cosine of 39. So this cancels out or reduces down to 1, leaving me with just g on the left-hand side. And then on the right-hand side, I have 44 being divided by cosine of 39. And this is where I want you to stop for now. This is your exact answer.